Hey, what is up? My name is Mike and this is the Radical Academy. So in this video, I'll be looking at power. Okay, so now this is the second session from the video that I started this week, which was talking about kinetic energy as well as work. Okay, so the relationship between kinetic energy as well as work. Now this will be the continuation from where we left off. So if you're watching this video and you have not watched the other videos, I encourage you to watch the other videos because this is just the concept we are going to borrow. The power is the concept borrowed on the aspect of work done on an object. And by the way, if you're new to my channel, to this Facebook page, please don't forget to subscribe, follow and like this page so that whenever I post all the updates, all the new contents, you'll be the first person to receive all our updates. Okay, so now without much further ado, now let's jump into our main business. Okay, I believe that you have gotten your papers. All I want you to do and understand, for me and for you, if you want things to work out, if you want physics to become very simple, if you really want science to be very, very simple, I encourage you that you get a piece of paper. Once you get a piece of paper and just follow me, step by step as I get from one concept to the other concept, from one concept to the other concept. So ensure that you get a piece of paper and if possible, get your calculator so that whenever I bring up some of the, examples that requires us to be going through some kind of calculations, you are also doing the same so that, you're satisfied and you try to, confirm if the answers that I provide in this video, they are also correct as you are also going through the same exercise or whatsoever that I may actually bring as way of something that is similar to an assessment. Okay, now what is it that we need to understand about power? Power is something that that it requires some kind of energy. It requires some kind of, some forces that are acting on an object, okay, to move that object from the initial position to the other position of a period of time, okay. So now previously we saw the relationship between work done as well as kinetic energy and so on and so forth, and then I also gave you the concept, okay, on how we can derive the formula for kinetic energy, or rather the change in kinetic energy, and then showed you how the relationship between energy and work, which we said that are force and distance, okay, force times distance equals to the change in kinetic energy. But of course, there are some of the factors which you must also consider, okay? There are some of the factors that you must be able to consider because, an object might start from, zero as the initial velocity and then goes off over some other final velocity, okay? So if the initial velocity is zero, then that's when we properly get that, the formula for power, kinetic energy, okay? So now in this, in this tutorial, I'll be walking you, through power, which is a very simple concept to understand as long as you understood the previous tutorial. So I encourage you, if you did not go through my previous tutorial, please go through so that whenever you can come back and watch this video about power. Okay, so now I'm going to provide a definition of power so that we get now started, okay? So now the definition of power so that is how simple definition of power is, okay? So we define power to be the rate at which work is done, okay? So we are just simply talking about how long is it going to take something, okay, to be moved from one position to the other position, and how long can it take, okay, with a different object of different mass, okay, how long can it take to be moved from one position to the other position, okay? So now, with that said, now we can provide a very nice and simple, formula for calculating the power that must be done on an object depending on how much mass the object has or how heavy the object is. Okay, so this is the formula. So power equals to okay, so now what you're saying is that the formula that you can use for calculating power is as follows. Power equals to weight done on that object, and then over the period of time for which it took, okay, for you to be doing some, work, or for you to perform some of the thing that you might be performing some work, okay. And then you can see now the units for power is joules per second. Okay, so the units are just gotten from the same quantities work, which is measured in joules, and then the time here is measured in seconds. So ensure that you understand that the time is measured in seconds. Okay, now power can also be measured in watts. Okay, so this is an example of some kind of electrical unit, okay, in which power is measured. Okay, so now I'm going to provide you with an example so that we can see how we can apply this formula. So I hope and believe that you have gotten something. Okay, so just understand what is power, the units of power, as well as how can you apply this formula in a scenarios or questions that I may come across, or from the past papers, or in an exam, or in a test. How can I apply this formula? Okay, so now let's now see that exact example, how it's going to look like. Okay, so now before we get to the example, there's some of the things that we're supposed to note or actually bear in our mind as we come to the example, because not really to the example, but we need to have this concept that we need to understand where power is concerned, and that's why I've written that keynote in the red marker. So let me just check it out. Now we are saying that most of the aeroplanes, jets, they need to be given a maximum, okay, a maximum force. A maximum power. Okay, so they need more power, or they need more force for them to actually take off. Okay, when the aeroplane or the jet aeroplanes, they're about to take off. Okay, so they need much more of the power. Okay, so this power is what is causing them, okay, to overcome the friction, to overcome the gravity that is pulling it downward, as well as any kind of external forces that are acting on the aeroplane. So they need so much of the power in order to just get out of these external forces, okay, that might be dragging the airplane or whatsoever the object we are trying to consider. So much more in the case of aeroplanes, they need now to be given so much power. They need more force, okay, to overcome all the drag forces and everything that might be pulling them backward, okay, in an opposite direction. So now, the moment an aeroplane takes off, okay, so the power now needs to start coming down, okay, so the power needs to start coming down, because as it is now moving away from gravity, okay, where there's so much gravity, okay, then it's trying to reduce in terms of mass, okay? It's trying to reduce in terms of, its total weight or its total mass and everything, okay? So the higher it goes now the less it becomes, okay? So now it can now move at the steady, a speed, okay? Unlike when it is closer to gravity, okay, to the center where gravity appears to be concentrated on. Now, with that said, I hope you have understood the key concept that you needed to understand, okay? So, this is the note that I've been talking about. Jet aeroplanes must be given maximum power when taking off from a runway to accelerate, okay? At takeoff, the plane has maximum mass. Once at cruise now, that is now it is away from the gravity point of view, then less power is needed now to keep the aeroplane or to keep the plane traveling at the steady speed. Okay, so that's everything you needed to understand about traveling at the steady speed. Okay, so that's a major key concept to understand over there. Okay, so now we can now head over to the examples, and then we shall conclude this section under kinetic energy and work done. So that's power, and then we shall move on to potential energy, and then probably wraps up, we're going to wrap up the topic, and then we shall get to some other interesting topic, maybe radioactivity, which is also there, but I didn't finish it, but we can now reintroduce and do some, workings from there. Okay, so now let's jump right into the examples. You can see now the examples is the first example is saying a trailer is pulled by a car with a horizontal, with a horizontal force of 1,000 Newton, so that it moves a distance of 300 meters in 60 seconds. Okay, that is 60 seconds along the horizontal road. Okay, so it's the flat and straight kind of a road in which the trailer is, and then the car is pulling the trailer. So we have to find out how much of the power did the car have to use in order to move the trailer or to pull it on the other side along the same horizontal force, road, within this period of time, which is 60 seconds, which is 1 minute. Okay, now what is the average power exerted by the car on the trailer? Okay, so we need to find the average power that was exerted on the trailer, or that was used in order to move the trailer to some point, okay, from that initial point to somewhere else. Okay, now the second example is saying a force of 588 newtons acts on a box to move it 4 meters in 4 seconds. Okay, find the power used. Okay, so I hope you have taken note of these questions so that when you begin to answer them, you will be you also be able to follow exactly, and then see how you can actually utilize the formula. Okay.